last video for the practice test. Just to go back to question 32, because I kind of, I'm not sure if I explained that well. I assumed that when we went from this step to this step, we have to remember that E equals V over D, electric field strength equals voltage over distance. So that's how this became that. Okay, so now let's move on to the next question. 33. 33 says, in a scattering experiment, alpha particles with the kinetic energy of 1.5 times 10 to the negative 12 newtons are fired at thin metal foil. The speed of the alpha particles is, well, I mean, that's really a physics 20 question, isn't it? You don't even have to know anything about the scattering experiment. It's simply a kinetic energy question. They give you the kinetic energy question. It's an alpha particle, so you know the mass of an alpha particle is on your formula sheet. Solve for V. V equals 2 EK over M square root 2. That's the mass of an alpha particle. Stick those numbers into your calculator, and you're going to get 2.15 times 10 to the 7. Meters per second. Number 34, which subatomic particles will leave tracks in a bubble chamber? Only ones that have a charge. So protons, alpha particles, neutrons. 1, 2, and 4 is the answer to that question. Number 35. Charge to mass ratio question. It's a proton accelerated at that velocity. You've given the radius, you're given the magnetic field strength. Charge to mass ratio, we should probably have that memorized by now, is just the velocity divided by the field strength times the radius. All the information is given to you. Change centimeters into meters. Make sure that you acknowledge that's 80 milliteslas, so times 10 to the negative 3. Stick the numbers in. I don't think I need to go over that in any great detail, and you get an answer of 9.55 times 10 to the 7 coulombs per kilogram. 36 says, use the following list to aid in your analysis of the particle tracks. Identify the two most probable responsible for this photo. Okay, so we have a branching track. One's being deflected down, one's going up. So one must be positive, one must be negative. The size, the radius of these two, now while you could argue, oh, it looks like the radius of the lower one is a little smaller, they're still close enough that those particles must have approximately the same mass. So if you've got to pick a positive one and a negative one, and they have to be relatively close to the same mass. And what's the only combination that's going to work there? It's going to be the positron and the electron. Right, because, well, let's just go through, I mean, it's good they put the antiproton in there. So an antiproton would have positive or negative charge. It would have a negative charge. It would be some negative proton. So if you said, okay, well, it could be the antiproton is my negative, then my positive would have to be the alpha particle, right, or the positron. Could be the electron and the neutron. Neutron's totally out of the ball game. Forget the neutron. So it would have to be the alpha particle or the electron. If it was the alpha particle, an antiproton and an alpha particle, what's the relative masses? Well, an alpha particle is essentially 4 protons, 2 neutrons and 2 protons. So it's 4 times heavier. So it would have a much bigger radius than the antiproton. And so on. You can go through all the permutations, but the answer, the only one that it's legitimately could be is positron and the electron. Number 2 more. Use the following lists. So we've done this already. The fundamental force that is strongest over the largest. No, you may have to think about this one a little, because it says the one that's strongest over large distances. We know that the nuclear force, the strong nuclear force, is extremely strong. It's the strongest force we have, but that's over very short distances. So this is over short distances. What about the other ones? The weak nuclear force is same. It's weaker. It's not as strong as the strong nuclear force. But again, we're talking about short distances because we're talking about the nucleus here. So you just got to decide between electromagnetic and gravitational, and not even close. The electromagnetic force wins out over large distances. So the answer to that one is 1. And then the last question, 38, we've done a question similar to this already, so I'm not going to go through it in any detail. We want the mass of an electron expressed in mega electron volts over the speed of light squared. It's simply E equals mc squared, using that mass, and then whatever answer you get, convert it to mega electron volts. That's your answer. It's 0.512 mega electron volts. All right, and we've done that question several times, so I don't think there's any need to redo it again. That's it. That's the end of the practice test. We'll see you for the final test.